Ladies and gentlemen, let me welcome you to today's lesson where we are talking about integration. Now, integration can be divided into two parts. The first part will be known as the definite integration. Then the second part, obviously, it will be indefinite integration. Now, what is the difference between these two? The only difference is that the definite integration will have limits. That means we will start from A until we reach B. Whereas for indefinite, we will not have such a thing. So that is the main difference between the two. And the second type, which is the indefinite, can also be observed as the reverse of the differentiation. Remember, the previous section was differentiation. So this particular type of integration can be observed as the reverse of it. So let's start with the latter. When we are trying to interpret this, what we'll end up having is that we will have the first sign or integral sign. The first part or the first sign, it will be an integral sign, where we can say in this particular section, since we are starting with the second part, we can call it indefinite integral sign. Then the second thing, it will be dx. Now, what does dx mean? Dx is called the variable of integration. So what do we mean by that? If we had d theta, that means our variable will be theta. If we have dr, that means our variable will be that r. So we will have that for dx, whether dx, dr, d theta, dp, d whatever, it will be the variable of integration. That means whatever thing that does not have that particular variable, it will be considered as a constant. Then we move to c, which is actually the constant. So if you want, you can even say the constant of integration. But that c is the constant, is the c that is only used in indefinite integration. When we go to definite integration, we have limits. Now we are talking about sums there, because we'll be using this integral sign will be taken as the summation from A till B of this particular function with respect to whatever variable that we'll be using. So that will be what will be considered our integral sign as for the first part. So in other words, we will not have c for the first part, but for this particular part, for the one that is indefinite, the reason we are saying it's indefinite is because the value for c is not known, or we are not given the value to find the c. So this c can be any value. It can be pi, it can be 2, it can be 18, it can be e, it can be any constant. So that is why we are saying it is indefinite. It's not definite. We are not getting the exact answer for it. So it stands as a constant of integration for indefinite integration. I think we are done with the symbols and terminology. Now let's come to the formula sheet. Alright guys, I do understand that some of us, since we did derivation, we are familiar with this formula sheet. I am so sure. Now let's refresh our memory. Let's say we are deriving a constant. What is the derivative of a constant? I will use, let me just look for a red marker to use for this one. Well, I managed to find the red marker instead. So it's a red pen, in fact. So let's suppose that we are asked to differentiate this, what you are seeing in front of you. Okay, now the derivative of c, since c is a constant, that means the derivative for the constant will give us 0, isn't it? That means the derivative, the integral of 0 is c. Wow, really? Okay, then what about c? The integral of c, what will it be? Okay, let's see. We'll just multiply by x everywhere where we had c. C could be anything. C could be 2. Let's move further. Let's say now we are asked to derive this one. If you are deriving it, remember we said that you'll bring it to the front, so you'll have n k x n minus 1. Okay, we have it. Now, let me use a different color when I am writing on this side. I'll have c times x there. I'll use a black marker on this side. So we do have our derivative of this one. Now, in other words, when we have this already and we are moving to our left hand side, we will be integrating, because integration can be observed as the reverse of differentiation. Alright, so from here towards our left, now we will have, it will be x raised by n plus 1. Then you divide by the new exponent or new power, whatever you want to call it. But I think we can already see there will be a problem somewhere, somehow here. For now, let's just leave it. I will just write the derivative on this side, all of them, and then I will come back here later on. If you are differentiating ka raised by x, obviously we'll have it multiplying by the ln of the base. Okay, come here again, we do the same thing. Now we have n next to our x. That means we must bring the exponent to the front, and then because this is an exponential term, this is an exponent, or our x is an exponent, so we should multiply by the ln of the base. Quite nice. We apply the same rule for e. Okay, so we have e, we have an exponent. Now we will multiply by the ln of e, of the base, which is e, as we did there. But we know that ln e is equal to 1, so that is why we do not write anything. The same thing will happen here. Ln e is equal to 1, so this is the answer for it. Now let me bring back the red pen again. Now let us differentiate ln x. 1 over x, or in our case it will be k over x. So in other words, this is equal to kx to the power minus 1. Right. Can we integrate this? Let's try to integrate this and see what happens. Now, obviously, if it's like this, we can use that rule. We want to check if are we gonna get the same answer, because if we use this, we know that if we go to our left, we'll get the integral of this. But now if we're trying to use this rule, we'll have in the place of n minus 1 plus 1, that is obviously 0. When you divide by 0, there is a problem. Remember, when we're doing limits, we said that we are not allowed to divide by 0. So the problem is in dividing by 0. The moment you divide by 0, there is a problem. Change the strategy. So that will mean there is an exception. So if it's an exception, we will write here, we only use this rule if n is not equal to -1, because when it's -1, we are not getting the solution. So this rule works on every exponent of x except when that exponent is -1. I hope that makes sense. Okay, so we've answered this part. That is why I wanted to write it with a red marker, so that you can know that we are not supposed to be tempted to use this when we see -1 as an exponent of x, okay, or as an exponent of whatever variable that we'll be using at that particular time. And okay, we can follow the same concept. In fact, now if we need to derive the log, what we'll do, which will be the k will be on top, k. I'm supposed to use the green one, the green pen, else, so that I maintain the same thing. So it will be k divided by x. Now this x should be multiplied by the ln of the base, which is a. We do the same thing for this one. It will be k divided by x times the ln of the base, and the base in this case is 10 because it's not given. When there's no base, the base is 10. Reverse this derivation. We are here, we reversed it to here. From here, we reversed it to here. Okay, this, if we're given this, we can reverse it to here. Now, if we're given this, we are asked to integrate it. How do we do it? Alright, we can copy from what we did here. Now, let me use this example again to do the same thing. When we were deriving, we multiplied by the exponent. But now that we are integrating, we divided by the exponent. But the difference is that here we multiplied by the exponent before we subtracted 1. Here we first add the 1, then we divide by the new exponent. So it's the same thing, or is the same principle will follow here. Here, but this time we won't focus on the exponent only. We'll focus on anything that we multiplied by, except k. Okay? So when we're deriving a raised by x, we multiplied by ln a. So in other words, when we are integrating the same, we will divide by ln a. Okay, let me show you. We have our k, a raised by x divided, we multiply by ln a, so now we should divide by ln a. That's how we do it. So we have our k, a raised by nx divided, we said that we multiply by n and ln a, so now we'll divide by n times ln a. What about here? We were supposed to divide by 1, but dividing by 1 does not make any effect, so it will remain as k e raised by x over 1. Over 1 doesn't make any difference. Let's come to this one. It will be k e raised by nx divided by n times 1, because ln e is 1. Okay, I can even move a little bit further. K e raised by nx over n ln e, but ln e is equal to 1, so therefore we will have the actual answer being ke raised by nx divided by just n. So this is the integral of this one. So now we are here. This will move to here. But when we are here trying to move to this side, we do not have a clear way of doing that. We will learn how to move it. We'll use other methods, in fact, to move it. We'll learn it later on, maybe when you're doing N5 and N6. Then they'll teach you how to do it that other way. So for now, we will leave it blank. We will say we do not have the integral of this one. In other words, this will not be asked for you. You will not be required to know this at this level. So it is beyond the scope of our syllabus for now. But obviously, when we go further, you know, I once said the other time, what is a lie from a certain level or from a certain grade can be justified and become true in another grade. So it's the same thing here. What this we know for now that does not have an integral. All these three do not have an integral. But when we are doing the higher levels, we will be asked to integrate them and we will have integral, but obviously there are ways to do that. Okay, let's move to sine. Sine x, when you derive sine x becomes cos x. Now when you integrate cos x will become sine x obviously, but when you integrate sine x, you are expecting a negative sign. So you will have a negative cos. That's what we will have for this one. Then what about the one that we'll experience when we have bx? Let me just put these brackets here. We are here, we are integrating this. We know that there is a negative. So this is what we can do. We can say negative k. When we were deriving multiplied by b, that b was multiplying. And now we have a concept that we have grasped from that one. We have grasped this concept from that. We were multiplying when we were deriving. Now we are integrating, we will divide, because we are using it as a reverse operation of derivative. So we're dividing by b, then we'll have our cos bx. So this is what we will have. When I'm looking on this side, there is no way where I can relate tan with. Okay, but fortunately, look to your formula sheet. Can you notice how to integrate tan? So we'll just take that integral. Alright? So it will be k. For sec, we will have basically this is what we will be doing when we are integrating. I just showed you the skeleton of what we'll be looking at. So now I've made for myself a new formula sheet that I can just look at when I am integrating. If I am here, I can move to this side. Okay, in some cases, when I'm here, I can look to this side. If you want, you can do a similar, or you can do the same formula sheet that I've just done, but now the problem will be, you will only use it whilst you are practicing. When you are writing the exams, you will not be allowed to come with your own formula sheet. You can have this just for practicing, or if you want to practice using the real formula sheet, just look at this as a way of studying, but every time you are integrating, you use the formula sheet that you will get for the exams. So the one that is in your question papers. This is one thing I want you to also notice. Here I've written integral of y with respect to x. Then I say the integral of f of x with respect to x. Alright, so this is the ways you can write this integral thing. You can write it in these two ways. What about y? You can write y as y or just a function of x. When we come to derivation, we can have dy over dx. Now, if in the place of y we're using f of x, we can have d over dx. Then we put the f of x. Some of the times we can do this. Now, when we do it this way, we will not have dy over dx is equal to, again, d over this thing. No. We will just use this without any equal sign. Then the equal sign will be on the next step. So this is the second option that we can do. The third option, you can just, I'm sure you know this one from high school, because we have that prime. F prime of x is definitely the derivative of f of x. Some of the times as we progress, we will also learn that y prime is also the derivative of y. So these are the 4 ways of writing the derivative. These are the 2 ways of writing the integral. See you on the next video.